There is one more aspect about PV diagram that I didn't introduce, that is your sign convention. So we are looking at sign when it comes to PV diagram. So there are three possibilities. One is positive, one is 0, another is negative. So there are three possible signs, is it not? So we are looking at works sign convention when it comes to PV diagram. So if you do a positive work, so basically there are work done by the system. Here work by the system is 0, and here the work on the system is what we are looking at. So whenever work is positive, the work is done by the system. Whenever work is negative, work is done on the system, right? This comes from the formula delta U is equal to Q minus W, right? So it comes from this actually. So all of this adds up. I've spoken about this. So by the system means positive means the system is losing energy. Work is done on the system is negative. Negative of negative is positive. I hope you guys understand that and remember that. So when we have positive work, the graph will generally look like this. So again, the thumb rule is that it will start from the left and go to the right. There are many possibilities. Even this is also a possibility wherein you are moving from the left to the right. It can be a straight line or it can be a curved line. Anything is possible. These are all these are some of the possibilities. So the point is you start from the left and move to the right. So this is a scenario wherein work is done by the system. So you see a graph which is of this manner. Work is done by the system. If you see the starting point and the ending point to be the same, right? Something like this. So V1 is equal to V2. Then there is no work. Basically, it means what? The piston is not moving. So this indirectly means the piston is not moving. Is it not? If you think about it, volume is not changing. Pressure can change like a cooker. In a cooker, the pressure increases, but nothing moves per se. So if you somehow maintain it, the system will be stationary. So no work can be done by the cooker, right? Cooker can't act like an engine because the piston is technically stuck over there. So no work is done. Pressure can increase or decrease, but the volume will remain the same. So this is the case of cooker. In the last case, if you see this kind of scenarios, that is, it starts over here, and I'm drawing it ulta because that's convenient for me. But in terms of arrows, it is this what we're looking at. So all of this is where it can start and end on the left. Again, the end can be anywhere, but point is it's moving to the left. So here V1 is over here and V2 is over here. Again, in the first case, V1 to V2 is to the right. Second case, there's no movement. Third case, V1 is to the right and V2 is to the left. So if you see such graphs, then the work is done on the system. If you see such graph, the work is done by the system. So here I'm using square as the end point and dot as the start point. Actually, I should be writing it the other way around. Start, and this is the end of the process. So this is how you represent in a graph. This is how you get to understand if the work is done on the system or by the system. So these are the three possibilities. So you have expansion, compression, or constant volume. So expansion is left to right, volume is increasing. Compression is right to left, volume is decreasing, and no change. W is greater than 0, W is less than 0, and so on and so forth. So this is one perspective. Another perspective that I want to introduce is, see, when it comes to mechanics, right? From mechanics, you have work is equal to force times of displacement. Now, in thermodynamics, right, the same thing if I happen to keep a thermodynamics mirror. So if we keep a thermodynamics mirror, what do we see? The force is because of the pressure that is acting on the area of the piston, right? If you have a piston, so this is your area. So your pressure acts on this, or this space puts pressure on the gas, or the other way around. So basically you have the pressure and area concept. When it comes to displacement, it is nothing but the movement of the piston, right? This is nothing but movement of piston. And as a result, when we look at the work is either expansion, the piston expands, the region expands, or it compresses. So this is how you get to look at work as pressure times change in volume, because area into displacement is, right? So we are looking at pressure times area times displacement. So this is nothing but your volume, and pressure is pressure, and this would be your result. So total work would be sum of all the small work that we get to see from volume 1 to volume 2. So indirectly, we are talking about the following result. So mathematically, the work done, you can figure it out with this. So we actually have two perspectives that we learned over here. One is graphical perspective, and another is mathematically how it looks. Okay, so let's, you guys can either start from here. Then I think you guys can take a note of this, or add to that graph whatever you guys drew. Then moving on.